everyone. Welcome to another video of our channel Statisticians Hub. Today we shall listen to the experienced teachers of our department. They shall discuss about 5 common questions generally asked in jobs, interviews, where the knowledge of the candidates in statistics is to be tested. Here, the focus is on statistics jobs of faculty recruitment in college, university, or in government sector. However, the questions generally asked to a corporate statistician recruitment is not in our agenda. So come on friends, let's get started.
Binomial distribution is one of the very basic probability distributions of statistics. Most statistics programs in the probability distribution course have a chapter on that. All the applicants for jobs with statistics background are expected to answer questions like what is binomial distribution, or what are the properties of binomial distribution, or tell something about the binomial distribution. This is one of the starting questions of a statistics interview. Generally asked to acclimatize the candidate with the interview environment. Since the candidate is expected to answer this question correctly, so responding to this, the candidate is expected to gain the necessary confidence and participate in the interview. Dr. Jonali Gogoi comes up with a precise answer to that.
Binomial distribution was invented by James Bernoulli in 1713. Let n, small n be the finite Bernoulli tiles with a probability of success small p and probability of failure small q. And the probability mass function of binomial distribution is probability of capital X equal to small x, which is equal to ncx p to the power x q to the power n minus x, and here x goes to 0 to up to small n, and 0 less than equal to probability of x less than equal to 1, and p plus q equal to 1. And the main features of binomial distribution is if we consider small n equal to 1, then binomial distribution reduces to Bernoulli distribution. And here in Bernoulli distribution there are 2 parameters, small n and p, and the mean of the binomial distribution is np, and the variance of binomial distribution is npq, and MGF of moment genetic function of binomial distribution is p plus q e to the power t whole to the power small n, and characteristic function of binomial distribution is q plus p e to the power it whole to the power small n.
Dr. Rama Shankar of Assam University comes up with an interesting interview question. What is the difference between random sampling and simple random sampling? This is a very tricky question for statistics interviews. Let us listen to him.
In simple random sampling, there are 2 terms, simple and random. But there is a difference between simple sampling and random sampling. In case of simple sampling, each unit of the population has an equal and independent chance of being included in the sample. Whereas in case of random sampling, each unit of the population has an equal chance of being included in the sample. Now, random sampling does not necessarily imply simple sampling, whereas simple sampling imply random sampling. Let us consider an example. Suppose there is a bag in which there are a number of white balls and b number of black balls. Now, at the first draw, the chance of getting white ball is a by a plus b. So, at the first draw, each white ball has an equal chance of being included in the sample. Now suppose one white ball you have taken and we have removed it. So the remaining white ball is a minus 1 and the total number of balls in the bag is a plus b minus 1. So at the second draw, the chance of getting a white ball is a minus 1 by a plus b minus 1. It means that at the second draw, each remaining white ball a minus 1 has equal chance of being included in the sample. So here the probability or the chance of getting a white ball at the first draw and the probability of getting a white ball at the second draw when at the first draw the ball has been drawn and not replaced are not the same. So here the sampling is not simple because the chances are not independent. Although the sampling is random, but it is not simple. Now the question is when the random sampling will become simple sampling? It will become only when the sampling is done with repeat.
Statistical inference is one of the favorite topics in interviews. Our next question concerns that aspect. This is a general question on statistical inference, where the interviewer wants to know how seriously the candidate has gone through the different aspects of statistical inference. This basic question, what is inferential statistics and what are its different parts, gives us an idea about how prepared the candidate is and how well he or she is prepared. Let us listen to the answer to this query from Professor D. Bhattacharjee.
Inferential statistics is that branch of statistics where we actually make a statement about population or the characteristics of the population based on some sample observations randomly collected from that particular population. So this is the basic definition of inferential statistics. Inferential statistics has primarily three parts: estimation, testing of hypothesis, and confidence interval estimation. In estimation based on sample observation, we are trying to estimate the value of the parameter. We take the help of sample observations and then with the help of some sample statistic try to estimate what the value of particular parameters may be, like population mean, population variance, etc. When we will go to testing of hypothesis, we have some prior belief, some belief that we already have. This belief may be passed to us by some previous researcher, some people who have already worked in the field, and or some popular beliefs. Now we want to check those based on sample observation. So we collect the sample observation and with the help of some sampling statistic, we want to find out whether this particular hypothesis that we have about the population is correct or it is incorrect. This is a testing of hypothesis. And lastly, we have confidence interval estimation. Here we actually try to find out a range within which the value of the parameter is expected to fall. Now based on sample observations, once again we find out the upper limit and lower limit of the confidence interval. Here we can also tell about the confidence with which the value of the parameter falls within the range, like we can have 95% confidence, 99% confidence, and so on. So this is one way doing something like an estimate, but here we are estimating an interval, then a point value. And so estimation is a point estimation problem, and this is an interval estimation problem. In addition to these three, we have of late decision theory, where we have more than one decisions in front of us to take. So based on the sample observation, we will go with any one of the decisions, but with this decision we have some penalty also. With each decision we have some penalty, some risk is involved, and so this is a decision theory, a relatively latest aspect of inferential statistics.
What shall a data analyst do if the data is not normally distributed? Obviously, transformation. But how to do that? What type of transformation to apply and when? Dr. Tanushri Debroy answers these questions that are frequently asked in interviews.
Some linearized functions can be applied to transform skewed distribution to normal distribution. Some of the common functions are logarithmic transformation. This transformation is applied to transform extremely skewed distribution to less skewed distribution. It is mainly applied for right skewed distribution. Then comes square root transformation. This transformation is weaker compared to logarithmic transformation. It is also used for right skewed distribution. Then comes reciprocal transformation. This transformation reverses the order of the values. That is, the larger values will become small. but the negative values will carry on or keep its order. Then comes exponential or power transformation. This transformation is applied for left skewed distribution. Then comes the last one is Box-Cox transformation. This transformation evaluates all other transformation and chooses the best one.
Bayesian inference is a branch of statistical inference. This is an advanced topic which is generally covered in the postgraduate curriculum of most Indian universities. Candidates are expected to know the basic difference between classical inference and Bayesian inference. Interview board generally puts such question to clarify the candidate's aptitude towards higher level statistics. Dr. Vivek Verma answers this query.
One of the important questions that is inquired to us is about the difference between the frequentist theory and the Bayesian theory. There are three different possible ways to answer that question. First is based on the conceptualization, second is based on the estimation theory, and third is based on the interval estimation theory. The conceptualization of the frequentist theory says that in the frequentist theory, the data is considered as a random variable, whereas the parameter or true value is considered as the fixed characteristic containing parameter. On the contrary, in the Bayesian concept, the data is considered as a particular realization of the random variable which is considered as the parameter. This is the simplest conceptual difference between the Bayesian and frequentist theory. When we are going to talk about the difference at the level of estimation, then in the classical or frequentist theory, the estimates are based on the maximum likelihood principle. Means the data which is presenting the highest probable value at the likelihood level for the given or described statistical model can be considered as the estimate of the parameter. Whereas in case of the Bayesian conceptualization, the estimate is relying on the maximum a posterior values, which is nothing but the maximum value of the posterior in terms of the modulus estimate. The third is one of the basic conceptualization among the terminology of the Bayesian and the frequentist is the definition of the confidence interval and the credible interval. The confidence interval is frequently used in the frequentist theory, which says that if an experiment is get repeated of 100 number of times, then 95% of the times the true value of the parameter will lie within that interval. That is also considered as a random interval. Whereas in the case of Bayesian theory, that whatever we are going to estimate is considered as a fixed value, where the estimate or the interval is based on the probability that the value of the parameter will lie within that interval and can be considered as the most probable and the reliable interval for the estimation of that Bayesian estimate.